In this experiment, we're going to see what happens when you burn fat. Now, unfortunately, we can't burn the fat that's actually inside a human body because that would be dangerous. So instead of human fat, we're going to use duck fat. This is what duck fat looks like on the molecular level. Our other input is oxygen, a gas in the air. When we burn them, we want to find out what the outputs are. Remember that the law of conservation of mass says that the mass of the inputs, which are fat and oxygen, should be the same as the mass of the outputs, energy and something that we're not sure of yet. Let's see what happens when we burn duck fat. So I'm going to press start, and the scale has been balanced to account for the weight of the tin foil and the candle cup. So the mass of the duck fat before the chemical reaction was 9.89 grams. Now we can see the chemical reaction happening. The duck fat is burning with oxygen, just like the way that fat burns in our body with oxygen as an input. The law of conservation of mass says that the inputs should be equal to the outputs. But you might be noticing something. Let's fast forward to the end. Now the mass is 9.72 grams. Yikes. So our mass after was 7.92 grams. Did the mass increase, decrease, or stay the same? The mass decreased. Now this is a problem, because the law of conservation of mass says that the mass of the inputs and the mass of the outputs in a chemical reaction should be the same. Our data does not support the law of conservation of mass because the mass decreased. What do you think happened to the lost matter or the lost mass? Where did it go? I'll give you a hint. Think of the 3 states of matter. Where do you think the lost mass went? The lost mass was probably a gas. How can we keep track of this mass of the lost matter of the gas? Well, in our first experiment, we used an open system where the gas could escape. The mass decreased because some of the outputs were gases that escaped our system. We can improve our experiment by making a closed system that includes the mass of the gases by trapping them inside.